volume of prisms. In particular, this is the introduction to it. So if you do already know a fair bit about prisms, you might find this a little basic. Otherwise, it might be worth a little recap of firstly what a prism is, and then also how to find the volume of them. Let's start off with the most basic prism, what I believe is the most basic prism, which is a cube. So a cube is a prism because it's a square that's being repeated throughout the shape. So a prism is something that has the same cross-sectional area throughout the shape. And let's call that shape a solid. So I say solid because it's a 3D shape. So let's go cube. Cube, remember how to draw this one? You draw one square like this, another square like this, and then link up the vertices for a nice looking cube. So, what is the volume of a cube? Well, the volume of a cube, right, is made up of 1 cubic blocks. So we've got here length might be like this. So let's say this is 1 centimeter. Remember area, we were looking at, we maybe have to extend this and it might become something like this. And we say it's a 1 centimeter by 1 centimeter, therefore making a 1 by 1, which is equal to 1 centimeter squared block. Now volume is we continue this and go, okay, we've got 1 this way, 1 this way. What's the other dimension we could go? Well, we could make it 3D. So remember with the cube, making the cube 3D, you draw something like that. And it's a cube, so all of the sides are exactly the same. So it's 1 by 1 by 1, 1 by 1 by 1 is equal to 1 cubic centimeter. So all of these things are the same, basically. In terms of volume, it's a 1 cubic centimeter block. And that's why it's in cubes, because there's 3 dimensions to it. So let's look at this shape here. Let's say this is 2 centimeters by 2 centimeters by 2 centimeters, because it's a cube. Now, how many 1 cubic centimeter blocks would fit into that? Well, one way that's good to represent it is just by breaking it into blocks. So we can see here, this is 1 centimeter, and this is 1 centimeter. Here, this is 1 centimeter and 1 centimeter. So if we turn this front face into a grid, like we did with area, we can see that there's 4 1 square centimeter blocks at the front. Well, with volume, we know that it goes to 3 dimensions, so let's do the same for everything else. Okay. Now you may note that it starts looking 3D. Let's focus on this block here. Now this shape here is actually a 1 cubic centimeter block. How many do you see here? Well, we've got 1 here, 2 here, 3, 4. 4 on the top, and then we've got another 4 on the bottom. So how many cubic centimeter blocks are there? Well, we see that this block is equal to 8 cubic centimeters. Now, this is quite a process to do. So we can actually use another formula. The volume is equal to the length times the width times the height. So the height in this case is 2, the width in this case is 2, and the length in this case is 2. So volume is 2 times 2 times 2. 2 times 2 is 4 times 2 is 8 cubic centimeters. And this is where the most basic volume formula comes from. The volume of a rectangular prism or a cube is length times width times height. Okay, so that's our first introduction into finding the volume of a prism. Firstly, we need to find how many 1 cubic centimeters or 1 cubic meter blocks will fit in. So let's just do a couple more examples. Let's look at a rectangular base prism, and then we'll look at a triangular base prism. Okay, so rectangular, you may have something like this. And I just want to show you another strategy for doing these. So let's say this is, let's call it 3, 2, and 6. So we could break this up into this is 3, this is 2, this is 1, 2, 3, 4, 5, 6, this is 2, and we can see that we can turn these all into little grids. Yet again, this is going to be quite annoying to do that. We can just go straight to our formula for a rectangular prism. The length, the width, the height, and let's just put all those figures in. 6 times 3 times 2 is 36, then we add our units, so let's call this one meters, meters cubed. Last one, let's look at a triangular prism. Connect the dots, and then we need to figure out the volume of this one. Now, a triangular prism you can think of as being half a rectangular prism. Do you see in this red box I've drawn, if I figure out the volume of that and divide by 2, or 2 of these triangular prisms could fit into this one, therefore the volume of a triangular prism is half of that of the same rectangular prism. So where does that come from? Well, another way you can think of it is this. We've got this base area here, don't we? And it's repeated along until it gets to the end of this shape. So how long has this been repeated for? It's repeated for the length of the shape. So what we need to do instead is we can just find the area of the base and times by how long, the length, that this area goes on for. So think of it like stacking on top of each other, in this case layering on top of each other. That's another way that we can figure out the volume. So here's a more powerful equation for prisms. The volume of a prism is equal to the area of the base times by the length that that base area is continued on for. So let's apply the same methodology here. Let's say that the base is 2, the height is 3, and it goes on for 10, and let's say our units are all centimeters. Let's use this formula now to help us figure out this problem. So, volume of the prism is equal to area of the base times by length. Well, we know the area of the base is a triangle. So the triangle is half times base times height, which is half times 2 times 3, which is 3 centimeters squared. So we've now found the area of the base. Now we can work out the volume of this prism. The volume is equal to 3, which is area of the base, times by length, which is 10. So therefore, this must be 30 cubic centimeters. So here's another strategy for helping us solve prisms by finding the volume of the prism is equal to the area of the base times the length. So in the next lesson, we're going to be exploring a bit more about volume, okay, and actually applying it to some shapes with some key formulas. So stay tuned for that.